Mhm. See, the synchronous or clock. Synchronous means what? They will have a clock pulse that we know. Every flip-flop will receive the same clock pulse. Sequential circuit can be divided into two types. One is called Moore or Moray or Mori or whatever you want to call it, Moore model, and another is called Mealy model. What is the difference between Moore and Mealy? Just very simple. In Mealy, the output depends on both the present state of the flip-flop. Present state of the flip-flop means what is the output of the flip-flop at present. That is what flip-flop is storing. If flip-flop, JK flip-flop, its QN is 1, then it will always remain in 1 unless and until another clock pulse is given or the input is changed. It will always remain to the present state that you know already. So Mealy circuit are those circuits for which output depends on both present state of the flip-flop and as well as the input. Whereas Moore circuit output depends only on the present state of the flip-flop. That means the output does not depend on the input. Rather, output depends on the state of the flip-flop, what the flip-flop is having now, what is QN in the flip-flop. It depends on that, not on the input. That is the difference between Mealy and Moore. For the sake of clarity, this is a Moore model. In this Moore model, you will see that the input X does not depend on the output Y does not depend on X. The output Y indirectly depend on X, but not directly depend on X. The output Y depends on the state of the flip-flop. It depends on the state of the flip-flop. So this is a Moore model because output depends on the present state of the flip-flop, but not on the input. In case of Mealy, the output depends on the present state of the flip-flop, as well as it depends on the input because the input is connected to the AND gate and this output depends on the input also. So this is an example I'm doing. So what is the difference between Mealy and Moore? Moore, it depends only on the present state, whereas Mealy, it depends on present state as well as the input. Input change does not affect the output. Obviously, no need to write as a point. This is common sense. Because input change does not affect output, obviously, because output doesn't depend on the input. Why are you writing this again? No need of this. It's a common sense. Moore model required more numbers of steps for implementations of same function. Okay. It required less number of steps for implementing the function. Okay. So for implementing the function means we are going to implement a function. Circuits we are drawing, whatever till today what we are doing, we are trying to find output, your output in terms of Boolean expressions. B-O-L-E-N, Boolean, B-O-L-L-E-N. I don't remember. In terms of Boolean expressions. In terms of Boolean expressions, we are trying to get the output. So more required more number of states. You know what is a state? We have design counters we have the design decade counter. It is having 10 states. So like that, more models may require more number of states to implement a particular function as compared to Mealy. Mealy will have lesser number of states to implement the same function. Now, this is called state diagram. This is called state diagram. Are you familiar with this? No, but we are a little bit familiar because just now we have done decade counter, mod 10 counter, and in that mod 10 counter, we have defined state, state A, B, C like that. Here, how many states we have? A, we have B, we have C. You can change the sequence, and we have D. I make it A, B, C, D because it is 0, 0, 0, 1, 1, 0, 1, 1. That's why I just think this to be A, this to be B, this to be C, this to be D. Therefore, you can also write A inside this instead of 0, 0, B inside this instead of 0, 1, C can also be inside this instead of 1, 0. Likewise, D can also be inside this. That is called state diagram. After state diagram, just now also in counter, we have A, and A we represent by 0, 0, 0, 0. B we represent by 0, 0, 0, 1. Like that, it goes up to J, and we represent it by 0, 0, 0, 1. That is 9. That was what we have done just now in case of decade counter. And we came to know that if I have to count from 0 to 9, I require 4 numbers of flip-flop. So I have to have 4 numbers of bits. That means 4 numbers of flip-flop. Here, in this case, you have only 4 states. So if I have only 4 numbers of states, then only 2 bits. Only 2 bits is enough. Is it okay? What I'm saying?
Yes, sir.
Yes,
So,
sir.
so that is why A, I am representing it by just 2 bits. B, I am representing by just 2 bits. If I have more than 4 states, say for example 5 or maybe 6, then I cannot represent A with 2 numbers of bits. I have to represent it with 3 numbers of bits. Is it okay? Can you understand what I'm saying?
Yes,
Do you
sir.
understand? Do you have any question? So if you don't
No, sir.
respond, then I will treat that you don't have any questions, and I will go. No problem. Whether you understand or not, if you are not asking, then I will treat that you have understood it, and accordingly, I will ask questions in the exam also. Because you people are smart students, you know everything. This is a Mealy circuit. This is a Mealy circuit. How do you know, sir? I will tell you. First, let us understand this. What is this? There is a state called A, and the state is represented by 0, 0. Representing a particular state by binary bits is called state assignment. I am assigning state with binary numbers. How many binary numbers is required depends on how many number of states you have. If I have 10 numbers of state in my diagram, I cannot represent every state by just 2 bits. It is quite obvious, very easy. We can understand it. Now, what is the meaning of this diagram? This diagram is just like, say, for example, this diagram is just a model. A person has come to me with this diagram, Not this diagram, not this diagram. A person is coming and telling me, please design a circuit. The circuit in one state, in one stage, to the another stage it will go when the input is 1, and at the time output should be 0. And when the input is 0, it should remain in the same state. Can you understand? Like that, a person is narrating, I want a circuit to be designed accordingly. Then I have to listen to him carefully and I draw the state diagram. It is something like that. And I try to design the circuit that perfectly works as per his requirement. So let us say this is a state diagram. It is given in the question. I should be able to interpret it thoroughly. What is that? It is in state A. From state A, it will go to state C. When input is 1 and output should be 0. When the input is 1, output should be 0. Therefore, it is a Mealy circuit because output depends on the input. On the right-hand side is the output. On the left-hand side is always the input. I repeat. From A, it will go to C. How do you know? Arrow indicates. From A, it will go to C. And during the time, if the input is 1, it will go from A to C. When input is 1. It will go from A to C when input is 1. And what will the output? Output will be 0 at that time. It will go from A and it will be in the same state A when the input is 0. And during the time, output also should be 0. This B will go to A when input is 1 and during the time output will be 0. It will remain in B when the input is 0. During the time output also will be 0. There is another state called D. It goes to B when the input is 0 and output is 0 at the time. It will remain in D when the input is 1 and during the time output will be 0. This state C will go to state D when the input is 0 and during the time output is 0. It will go to its own state when input is 1 and during the time output also is 1. Is it okay?
Yes, sir.
Yes, sir.
Will not go here because you'll get mixed up. I will tell you. Now, this is also a Mealy circuit. Why? Output depends on the input. Output depends on input. From A, it goes to C when input is 1, output is 0 at the time. From A, it goes to B when input is 0, during the time output is 0. From B, it goes to E when this is the condition. When B, it goes to D, D, it goes to D, D, it goes to A when this is this. So you can understand, right? Can you understand? It is very easy. The arrow indicates everything. Okay. Now these things, this thing, I will have to represent in a table form because I need to design a circuit and I can design it using any flip-flop. And for that, I need to know the excitation of those flip-flops, which I want to design. With any flip-flop, I can design. Now, in the same state diagram, I need to state table is required for this. State table, okay, state table is required. Be careful. Be careful in the sense, look carefully. A, 0, 0, B is 0, 1, C, D, everything is okay. Now you come here. See, now you come here. A is 0, 0. A is 0, 0. B 0, 1. C 1, 0. D is 1, 1. Okay, so you can write all these things, or if you don't want, you can keep it like this: A, B, C, D, like that. From A to A it goes when input X is 0. It goes from A to A when input X is 0. Is it correct? It goes from A to A. It goes from A to A. Yeah, A to A when input X is 0. Okay, now I think it will be difficult for you to go back, see here and there. So again, it will be difficult here to write. I have to close again. So writing in PDF, this is in PDF now. Writing it is very non. Cut is not possible. Cut. It did. It's very difficult. Okay. See, the table should be like this, like. If you don't see side by side, you will not understand. That's why I want to make it side by side. You can see and you can write so that you can understand. PDF in time to open, not responding. If I keep writing, it will take time. That is why I want to be fast. Is it visible?
Yes, sir.
Yes, sir.
Now you'll see. It goes from A to A when the input is 0. This is input. X is the input. Okay. X is your input. X is your input. This is your input. This is your, this is output. Obviously, output. This is Y. When X is the input is 0. X is the input. Input is 1. So it is just a translation in a table manner. Very simple. A, B, C, D, I call it. So from A to A, see, from A, it goes to A itself. When the you take up anything, you have to do it slowly, okay? And so let me, if I want to start from here also, no problem. It goes from A to C when input is 1. A to C, see, it is going from A to C when input is 1, because input, it can be 0, it can be 1. That's why input is 1. Where it goes to C. And when input is 1, output is 0. When input is 1, output is 0. It goes from A to A. It goes from A to A, A to A. When input is 0, when input is 0. And what about the output? Output is 0. Why? When input is 0, output is 0. When input is 0, output is also 0. Can you understand what I'm saying?
Yes, sir.
It goes from B. Okay, let us try to understand from here. It goes from B to B itself. B to B itself. When input is 0. When input is 0, come here. When input is 0, means X is 0. When input is 0, it goes from B to B. B to B when input is 0. And when input is 0, what will the output? Output also 0. When input is 0, see, 0, output also is 0. This is output Y. Output Y when input is 0, output Y when input is 1, it's condition. And from B, it goes to the arrow A when input is 1. B to A when input is 1. And when the input is 1, output is 0. When input is 1, output is 0. Is it okay?
Yes, sir.
Or in the exam, this is confusing. What you will do, you have to do like this in the exam. This will be very easy. X is my input. When it is 0, what happens? A. When it is 1, what happens? When it is A. When it is 0, what happens? When it is 1. When it is B. When it is 0, what happens? When it is 1. When it is C. When it is 0, when it is 1, what happens? When it is D. When it is 0, when it is 1, what happened to the output Y? Is it okay? This way also we can draw. Instead of drawing like this. X when 0, when 1. X when 0, when 1. This is A. State B, state C, state D. State A, state B, state C, state D. State A when X is 0, sometimes 1. State A when X is 0 or when X is 1. So if you write like this, it will be easy for you to design the circuit. Not like this. I don't say this is wrong. Okay, so now you see from A when X is 0, from A when input X is 0, it goes to A. It goes to A. Why? This is next step. It goes to A. It goes to A. And when X is 0, output is also 0. When X is 0, output is also 0. Finish. Now, from A, when X is 1, from A, when X is 1, it goes to C. It goes to C. And X is 1, output is 0. Output is 0. From B, when X is 0, from B, when X is 0, it goes to B itself. It goes to B itself. When when input is 0, output also 0. From B, when X is 1, B, when X is 1, yes, when X is 1, it goes to A. When X is 1, output is 0. From C, when X is 0, from C, when X is 0, yes, it goes to D. When X is 0, output is 0. From C, when X is 1, C, when X is 1, it goes to C itself. When input is 1, output also 1. When D, when X is 0, when X is 0, it goes to B. When X is 0, output also 0. When D to D, when input is 1, when X is 1, it goes to D. When input is 1, output is 0. This is actually equal to this table. Can you understand what I'm saying?
Yes, sir.
Now, this is just a state. I have to draw it in a similar manner in the sense A, I have to represent it. A means 0, 0. So this table will become like 0, 0. Here it will become 0, 0. So the next table should be, you are going to, because you cannot design circuit with A, B, C and all these things. So the next step is 0, 0, 0, 0. A means 0, 0. C means 1, 0. B means 0, 1. C means, D means like this. B means 0, 1. A means 0, 0. D means 1, 1. C means 1, 0. B means 0, 1. D means 1, 1. Like that. Can you understand? So this blue color will be the next step. Or you can merge it. If you are smart enough, you can merge together. Together means you can directly, instead of A, B, B, C, D, because you know A is this, B is this, C is this, D is this, you know. Directly you can write it also. It's up to you. If you want to jump one more step, no problem. Can you understand what I'm saying? So this is called state diagram, and this is called state table. Is it okay?
Yes, sir.
Yes, sir.
Is it difficult? No, it is not difficult. Is it difficult? No, it is not difficult. Just from the state diagram, which is going to be given in the question, it will be given in the question, the state diagram. And from this diagram, you are going to write a state table. From this diagram, you have to write the table. Just now I was writing like that, you have to write. That's all. Very simple. And
Excuse me, sir.
yes, you have class, no?
No, sir. At from 12 we have test, sir.
Okay, we'll wind up. You put the attendance and we'll wind up. No, you give your attendance, we'll wind up. You put your attendance, we'll wind up.